Hi, welcome back to Spring CS170. I just want to hit on a couple of little hints or updates before I get back to the PowerPoint. So one, here's the announcements, and I was just reminded that I should put my name on the bottom of the announcement so people know that I made the announcement. You don't actually see this many uh, announcements, or you shouldn't be. You can see I can select like 10 sections here. So I'm covering 10 sections here, and that's where I'm making my announcements. And you can see like the TA still make announcements to like 2 sections, right? So in this case, Weiji, who covers section 16 and 19, will make an announcement, and it should only go to those sections. So if you're getting a message, it should be coming from myself, Professor Trees, or one of your TAs. But I should sign it so you know it's coming from me, because I guess it's not abundantly clear that it's coming from me. Um, but uh, that's my little picture there, so I guess you should be able to tell that's me, right? But anyway, I will put that on there. The other thing is, and I just put this out, I think some people were looking at the video and didn't see that you can do a toggle between the small picture and big picture. Yeah, so you don't need to see a big picture of me. You want to see a big picture of this screen here. So make sure you hit this toggle here so you can flip that. Okay. Now, if you're looking at the YouTube video doesn't have that. So the YouTube video will just have this one screen. Okay. So that's that. Um, and that's it. I think the last one I made the announcement about including the student schedule on the home page. Again, hopefully that's helpful. Reduce the number of places you need to look for things. Okay. So anyway, let's get back to here. And I believe we left off over here. So let me step to here. Okay. So this is just a recap of what I was talking about before, where you're talking about these mechanical um, computing machines, right? Uh, like there's a Bacchus here and whatnot. There's a slide rule. You don't have to know exactly the details of how these things work. That's not really the point here, so don't worry too much about that. But just know that these are like mechanical computing devices. Okay. And then you got into like the electronic uh, computing, which is basically starting off with the vacuum tubes after World War II, so like the 1950s. And then ultimately you're getting into microprocessors and basically all kinds of computing on a chip, which passes through with the personal computer, and now a lot of you are doing stuff on mobile devices, right? Your phones basically. And Internet of Things and all that kind of stuff. So it's basically from like this big room size, unwieldy type of computing things to this intermediate step. It's still pretty big. To here, personal computer feels kind of personal. At least you can put it in your house. To something that you can just carry around or wear on you. Okay, so that's kind of the progression here. Okay, and you can see the same thing here. Right, so here's the computer. They open up a cell phone here, or mobile phone, and they talk about all of these. GPU stands for graphical processing unit. These are very, powerful computing chips, and more and more of the stuff is being compressed into a smaller space. But it still applies some of the general computing ideas or designs that was coming from Babbage, right? Basically, what we're saying, who we're saying is the father of computing. Okay, um, and we'll get into those details later on in the course. But basically, what you need to carry away from this is how things are getting more and more compressed into a smaller space. Okay. Uh, so we've just been talking about the hardware. Let's go over to the software side of things. Okay. So one of the ideas is this idea of a what they call layered software or a software stack. Okay. So usually what most people, normal people would be interacting with would be something, let's say, on your browser. You're watching a video, right? Those type of things. So that's considered what we call the top of the stack, right? That's the application level here. Okay. But that's obviously not where all your work is happening, right? So the lowest level is the hardware, right? Here at the bottom, right? That's the actual physical computer, but you need some software on top of that hardware for it to be able to do things, okay? And that's where you basically get into, this is what we consider like operating system level type of software, right? So when you think about like how to manage the power, how to connect to other devices, how to run other devices, um, how to manage the memory, all that kind of stuff that you don't care, but the programs that you use do care about that kind of stuff. So that's like the first level, first layer on top of the hardware. And then you have another layer, which is called the libraries and runtime. So that kind of sits on top of all these basic components or tools, and just makes it easier for developers to, or programmers to be able to do various things with whatever hardware they're on. Let's say it's the phone, okay? And then you have another layer on top of that. Again, it just kind of bundles things together and makes it easier for people to make meaningful tools or programs out of it. And then finally, it's the application level, which is what most of you will be interacting at. Okay, and as you work your way up, it's what people refer to as levels of abstraction, right? So things are bundled up, and you at the next level don't have to care about the lowest level, right? Usually, if you're at this level, you're like a user, you don't really care like how the computer manages its devices, right? Generally, you don't, right? There are a few exceptions, and I don't know if we really need to get too much into it. There are exceptions if you really, want to tweak something for a special purpose, or there's some particular performance issue, or whatever that you're trying to work on. But 99.9% of people don't care, right? And they're usually working at this level. Okay. So when you look at uh, abstraction, right? So it's this idea of like uh, allowing you to use something without fully understanding all of the different details. Um, so and then there's algorithm, which I'll step into a second. So there's a couple examples here. It talks about basically like an idea, and then they kind of put something else on top of it. In this case, they're talking about like a story or something, right? Put that on top. I like to draw like an analogy to maybe something else. Let me just pause here for a second so you can see this, and you can see what it's trying to abstract. Okay, and same thing here. Okay, so the way I look at the abstraction, and I don't know if some of you might grasp it a little bit easier, it's like when you get in a car. Okay, uh, when you step on the brakes, the car will stop. Okay, or if you turn the steering wheel to the left, the car will go left. If you turn the steering wheel to the right, the car will go right. Now, the fact that all that stuff doesn't happen like magically, um, for example, like for the brakes for the car to stop, there could be any number of things, right? It could be something that goes directly from your brake pedal that mechanically connects everything to the brakes to stop the car. It could be something where you just hit the brake pedal and it sends a computer signal to the brake pads, and the brake pads will clamp on the rotor and then the car will stop. Um, there could be any number of ways for the brakes to be implemented. But you, as a driver of the car, you don't care, right? And so that's a level of abstraction, or there could be, depending on how you look at it, there could be multiple levels of abstraction to go from the implementation detail to something that you are engaging or interfacing with. Okay, most of us are probably interfacing at what we would call the application level or the uh, user level. Okay, and then all the other stuff in between could be depending on who it is, right? So if you're an auto mechanic, right, you probably care a little bit lower, right? You care about some of the implementation side of things because you're actually working on either maintaining the car or fixing the car or making enhancements to the car or whatever. So you as a mechanic, you're going to be working at a lower level. Maybe you can call it a lower level of abstraction. Okay, so that's what abstraction is all about, right? So there's different levels of understanding about the same thing, right? Um, and I can give more examples, but I find like giving the car example seems to be something that most of us can relate to. Okay, for what you have on your phone, right? Everyone's carrying a phone, I think, or most of us are carrying as a phone. Uh, there's a lot of things that control, like let's say the camera on the phone, right? So a camera is a camera, and what you can do with it in terms of being able to smooth out images, make some images look brighter or darker, or all of that. Those are different pieces of software on top of the hardware, and depending on how you look at it, would be different levels of abstraction, right? If I'm programming to use a camera, I don't actually know about the actual implementation on how it does it, but I just know that I want to send a command to tell the camera to make an image brighter, right? Or to make the flash go off or something like that. Um, so, hopefully you get the idea of what I mean by abstraction and how it applies to the devices or the computing things that you do. Okay, so that's what abstraction is all about, right? Abstracting at various levels depending on what what your perspective is, what your view is. Okay, but yeah, I'm gonna save this to my material so you can look at this. You can look at this as an example for levels abstraction, or you can use what I just described to you for examples of abstraction, right? But do try to understand this. This is an important concept for the class, so do understand that. Now, algorithm, algorithm is basically steps to get something done. From a computer perspective, it could be like a program, okay? So, well, program's implementation of algorithm. I should be more precise on that, right? Um, so so algorithm here. Well, here's a recipe, right? That maybe that's the easiest way to give an example that we can all relate to, right? So you have basically a set of steps to get a particular outcome. In this case, you're getting a brownie, right? Well, a pizza brownie, I guess more specifically, right? And then so you have all the ingredients. How do you put all those ingredients together uh, and act on those ingredients? In this case, heating it up, right? To bake it and to produce this, right? Your pizza brownie. Okay, so that's what an algorithm's about. Likewise, for a computer, maybe I want a computer to calculate the final grade for everyone in this class, right? So what goes into that? Well, there will be all of the grades from your assignments, there will be the grades from your quizzes, there will be grades from your exams, there will be extra credit, uh, so on and so forth, right? So how do we put all those together with the different weightings and whatnot? There will be an algorithm to collect all that information, process it, and out comes a grade for everyone in the class, right? So the algorithm kind of just describes all of those steps. The program that we write, someone's going to write a program to do this, will implement the algorithm. Okay, so I hope that's all clear, the difference. Okay, so again, what we covered here for this lecture is this idea of abstraction and algorithm. Okay. Um, do let me know if there's any questions on this idea. Otherwise, we'll wrap it up and we're going to move on to chapter 2 for your next lecture. Thank you.